P.5 Factoring Polynomials. So we talked about polynomials in P.4. We actually did a lot of multiplication and separating them out, right? Like identifying each and every single division, each and every single term after multiplying or addition or subtraction. We're going to do reverse in this section. Factoring means taking polynomials and separating them back out into individual sets of parentheses. So this is sort of the reverse of what we did in the first section. If a polynomial cannot be factored, so we're first going to talk about sort of the negative of what's going on. If a polynomial cannot be factored, we call the polynomial prime. So we call it a prime polynomial. Or we might use the phrase that it is irreducible It's terrible. Try that again. Over the integers. Irreducible over the integers. I'm kind of a fan of prime. It's faster to say. That said, most of them are not going to be prime. If they gave you a whole bunch of primes, then you wouldn't have any practice in factoring, right? But do be aware that you could have something where they do end up giving you a prime factor or prime polynomial, and there isn't any factoring to be done. All right. Every time you're given a polynomial, the first thing you should do is to look and see if there is a factor common to everything. If there's anything that will take all of the pieces that you're given and divide all of them by something. A lot of times there's not. But if there is, you will find yourself thanking yourself over and over again that you did it, because it's going to make the rest of your life so much easier on this problem. Okay? Now in this example, that's the only thing we've got going on, so it makes sense. But in other examples that later on, if we find a common factor at the beginning, the rest of the problem will be easier to work with. So, common factor means that you look at the numbers in the front of each of your terms and you say, what can they both divide by? The biggest thing they both divide by. So I have a 12 and an 18, and what is it? It's a 6. So we're going to write down a 6. And then we look at the variable components. I have x squared and I have x cubed. What is the biggest x with a power they both divide by? X squared. So we're going to write down x squared as well. So 6 divides the 12 and the 18. X squared divides x squared and x cubed. So this is our greatest common factor. The next thing that we're going to do is we're going to write parentheses, and we're going to write what pieces, what factors, are left when we do the division. In other words, if I were to divide 12 by 6, what number is left? A 2. So the 2 is going to go right here. If I divide x squared by x squared, what's left? 1. It's not 0, actually, it's 1, but it's sort of like nothing's left, right? There aren't any more x's left, so it's the number 1. I don't need to write the number 1, right? Because 2 times 1's 2. I mean, it doesn't change anything, but make sure you're being aware that there's nothing left in terms of x values. All right, now we have the 18. 18 divided by 6 would be 3, and since the 18 is negative, it'll be a negative 3, right? So I have the minus already there. There's my 3. And then I have x cubed divided by x squared, which gives me x. If by chance you get to this point and you see that the parts that are in parentheses still have something in common, what it meant is that you didn't divide by the greatest common factor. There was something bigger that you could have used. For example, let's say you looked at the 12 and the 18 and you immediately thought 2, they're both even, I'll pull a 2 out. Well, if you did that and you got into the inside of the parentheses, you would see that they both still had a 3 in common. And you'd need to keep going, right? You'd need to do another step to pull the 3 out that they had in common. So as long as you're identifying the greatest common factor first, then you don't have to keep going because you will be done at this point. So good? All right. There are some special formulas, and I mentioned one of them just like, 3 minutes ago in the last video. One of the forms that I actually mentioned was called difference of squares, and I said, who's heard of that before? And most of you raised your hand. that first example, a squared minus b squared, is an example of a difference, difference means subtraction, of two things that are each squared, a and b. And it is a beautiful thing when this shows up because the factoring for it always has a specific form. The factoring for it says that it will be a minus b times a plus b. And if you multiply these back out, you will in fact get, of course, the a squared minus b squared. What would we call a minus b and a plus b as they relate to one another? Conjugates. That's what we just did, right? Those are conjugates. That's why when we multiply them back out, the inner and the outer terms are eliminated. They're called additive inverses. There's the inverses word that you had mentioned before. They're additive inverses, yeah. Okay, so that was a difference of squares. So if the first one's called a difference of squares, what do you think the second one's called? Difference of cubes. Difference means subtraction, and they're both cubed. What do you think the third one on this list is called? Sum of cubes, because it's an addition of cubes. Notice there is no sum of squares, right? If you had a squared plus b squared, it will not factor. It just doesn't. It would be called what? What's something that can't be factored called? Prime. It would be prime. Good job. You guys are remembering very well. All right, so let me show you how each of these factors, they're related to one another. So if you remember one, you'll probably remember both. So they have a factor that looks a lot like when we did the difference of squares. The first one will look like the same thing that's already there with the same sign, just without the cubes. Okay? So the a cubed minus b cubed will have an a minus b, and the a cubed plus b cubed will have an a plus b. So those pieces will be sort of like matching. The other piece is actually a trinomial. It will be the first term squared, it will be the two terms multiplied, and it will be the last term squared. The last term squared is always positive, and the middle term is always the opposite sign of the binomial. So in this binomial, I have a minus b. So this a times b here will be added. And on the bottom one, again, I have an a squared, I have an ab, and I have a b squared. The b squared is always added. But this plus right here in the binomial means that I will have a subtraction, a minus right here on the ab term. Okay? So you can see the similarities between those two formulas, yeah? So we absolutely have to do an example because otherwise it doesn't feel like we've learned it, right? We've just written it down, so we should practice one. All right, does everybody have this written down at this point? Yeah? Excellent. All right, here's an example. 9t squared minus 16. It's not a bad idea to start out the problem by recognizing what is actually being squared in each of the terms. Okay? 9t squared, what's actually being squared? 9. Not a 9, a t, and something else, a 3. There is a 3 squared because that's what makes 9. And there is a t squared to give me the t squared. If I were to distribute this out, I would get 9t squared, which is where I started. Okay? So I need to make sure it's really easy to forget about the 9 actually being a 3 when we're looking at the actual single terms. How about the 16? Yeah, that would be a 4 that's being squared. So those are the terms that are being squared. So if you're sort of thinking like identification, this is the A, and this is the B. A is 3t, B is actually 4. So in order to factor this then, I'm going to need two sets of parentheses. The formula says, or we'll call them formulas. The formula said we're going to have an A minus B and an A plus B. If you do A plus B and A minus B, that's fine. It won't hurt anything. But we identified our A and our B, so this should be pretty easy. Our A was 3t, our B is 4. So one of these is going to be 3t minus 4, and the other should be 3t plus 4. a little bit small. All right, so now think with me. In my math lab, it automatically gives you back feedback, tells you if you're right or wrong, correct? But when you're doing your written homework, unless it happens to be an odd problem that you can check the solution to, that's not the case. How could you check to make sure you did this problem right? You could multiply it out. You could go back through and actually do the multiplication. If I FOIL this out, I should still end up with 9t squared minus 16 when I'm done. Agreed? So it's almost like you have a built-in solution manual when you're doing these problems. Okay? So that's kind of cool. The next problem.
So that's just the answer?
Yeah, it is. That's just the answer. Yes, thank you. I should put it in print or in a brackets, in a box. That is our answer. 3t minus 4 times 3t plus 4.
What would the directions say?
They'll say factor. Good question. I didn't actually write it on the slide. I usually do. They'll say factor. How about 3? It looks like there's a cube because you should see the 8. And what is 8 if you were looking for the cube root of it? Maybe a 2. And the 27 would be a 3. So that's useful information. But there's kind of a catch. Do you see the problem with that?
You can pull out a common x.
Oh, yeah. So what you should be looking there and saying is, okay, that sounds good, except for this is x to the 4th, and that's not cubed, right? So there would be a problem. But if you look a little bit more carefully and you go back to what I told you over here on number 1, really, you should be looking to see if there's any common factors to begin with, and there was one. Both of these terms have an x in them. So we really need to start there by pulling out the common factor of x. Now, the 8 and the 27 don't have anything in common, so I don't need to do anything with the numerical values. But this would give me an x on the outside. I've got still the 8. X to what power? The 3rd. Good. And then I have a minus 27, and then what do I have? Y cubed. Now things look cubed. Yes, Jeremy?
Could you cancel out an x?
You can't cancel them. What you're thinking is either in terms of fractions, where we've got a value over a value for cancellation, or equations where we have two sides of equal signs, and there's addition and subtraction.
Okay.
So in essence, we're factoring out, we're pulling it out like we're dividing by it, but we're writing it in front so we don't lose it along the way.
Okay.
Yes. Okay, we already identified these, so I'm going to write them down. This is actually a 2x that's being cubed. And this is a 3y that's being cubed. Agreed? Okay, so this step right here is not really a step. It's me identifying the pieces broken down in a different way. That's all I'm doing. We're going to continue the problem over here. Don't lose the x. It's still out in front. But it is a difference of cubes. So we've got our x in front. We've got these identified as the a value and the b value. What will the first set of parentheses look like?
2x minus 3y.
2x minus 3y. And you are correct. How did you decide that it was minus?
Because it's the opposite of the first one.
No, it's the same as the first one. It's the same as the first one. Yeah, it matches. So this term right here being minus means this one will be as well. So they match. Okay, good. All right, the next thing I'm supposed to do is I'm supposed to do squaring of things, right? This first term in the trinomial should be the a value squared. So what happens when I have 2x and then I square 2x?
You get 4x squared.
I get 4x squared. Again, an easy mistake to make is to forget to square the 2. But I need to square the entire term a, so the 2 gets squared to give me 4. All right, the middle term is supposed to be the two terms multiplied. Whoops. So what are these two terms going to be if I multiply them together?
6xy.
Right, so I'm going to have 2 times 3 is going to be 6, and then I have the xy. So I'll have 6xy. What will the sign be on 6xy? plus, because it will be the opposite. That's what you're thinking of. It will be the opposite of the first one, right? So if this one's minus, which it is, this one's plus. So that's correct. And then at the end, what will I have?
Plus 9y squared.
Right, I'm going to square this term. The 3 gets squared to give me 9. And the y gets squared to give me y squared. Okay. Very good. We are going to stop right there. We'll pick up on example number 4 next time, and I will adjust this homework to be due on Friday next week instead of Wednesday. Have a wonderful Labor Day.